Hello, this is actually the attempt 2 because my computer had low space, but I will be covering the 2023 Invitational A of calculator applications. Certainly one of the harder Invitational A's I've seen, at least at the very end. So let's begin. Hopefully I don't go too fast because I'm kind of frustrated at my computer, but it happens, I guess. I'll be more careful in the future. Let's start with the easy ones I can knock out quickly. Put into your calculator product of 99.7, square root of 770. This is an EQ solver problem. Go to Math, scroll up, Numeric Solver, put them in, put it in this equation, and get the x value of negative 2.65. Make sure that your guessed value is also negative, or else it won't cross this asymptote right here. Number 8 is a similar one, cube root of that stuff right there, and you get negative 44.5. Okay, 9. The semicircle squared, or semicircle radius. The area of a circle is r squared times pi, but since it's a semicircle, you have to divide by 2. R squared over 2 pi times pi is r squared over 2 times pi is 54.9. And if you solve for that into EQ solver, like you should be using for all these problems, you get 5.91. Okay, 10, this is an area of a rhombus. It's pretty simple. 2 length times height, 2.31 times 2.01, 4.64. Done. Okay, what is the viewing angle of a rectangular picture frame? This is pretty easy as well. You just multiply the two values, and that is your area. 17. The distance from the pitcher's mound to second base, the base is 127.25 feet from second, and part of that is taken up from the pitcher's mound. So all you do is simply 127.25 minus 60.5, and you get 66.8 feet. 18. Okay, a supersonic transport flies at 1.7 times the speed of sound of 660. How long does it take to fly? 5,451 miles. Well, time is equivalent to distance over speed. So you do simply 5451 over that speed you have, and you get 4.86 hours. 19. Definition of inverse cosine. Cosine negative 1 of this value over this value. Just make sure you have it in radian modes. Radian mode. Cosine is adjacent over hypotenuse. You should get that. Okay, 20. Personally, when I'm solving these problems, I like to solve for this hypotenuse value instead of this value right here because it makes things easier with more easy to understand function or trigonometric functions. But basically, this x value or the area of the triangle is the length times the width over 2. So that means the length is sine of 53 times x, and the width is cosine of 53 times x. So you can see there, sine of 53, cosine of 53, x squared over 2 because it's a triangle, and you get 5,930. Then you simply have to multiply x by sine of 53 to get 125. Okay, Sam runs a mile in 6 minutes and 48 seconds. What's his velocity? Well, velocity is distance over time. So they want it in miles per hour. So let's do miles, 1 mile over this many hours. So 6 over 60 minutes to hours plus 48 over 3600 seconds to hours. If you do that, you get a speed of 8.85. The Mona Lisa is valued at 900 million. It is rectangular. By that was the value per unit area. So first off, you should figure out the area in terms of inches. 2 times 12 plus 6 is 30 inches. And then 1 times 12 plus 9 is 21 inches. Multiply those together. And the area is 630 inches squared. So now you go to Apps, scroll up, Side Tools, Unit Converter, Area. Now there actually isn't a millimeter squared thing here, but you do have meters squared. So what I'm going to do is do 630 inches squared. convert to meters squared, you get like 0.4064, and then you can multiply that value by 1 million or 1,000 squared to convert to from meters to millimeters. Then once you have that area, you simply do $900 million over that area, and you get your 8.62. Or sorry, I'm looking at the wrong thing. You get your 2210 right here, dollars per millimeter. It's important to note that this is technically not a dollar sign problem because this is a different unit. This is a dollar sign problem right here. The dollar sign will be in the front. But what this means is that you do round the 3 significant digits like normal. Next one, types of interest. Invest a good amount of money for 2 years at annual interest. What is the positive difference in total earnings if the money was compounded annually? Okay, if it was simply compounded annually, the rate would be your 1 plus your rate squared, or power to the amount of time you did it. However, that is only part of it, because if you're compounding a certain amount of times, you have to divide that rate by a specific number, and then multiply the power by a certain number. In this case, there are 12 months in a year, so that number is 12. You put that in your calculator, and you get 8.62 bucks. Not a very big difference. 29. The surface area of a cone. Well, there are two parts of this surface area. Actually, you know what? There's probably a better way. Now I'm thinking about there's a way better way to do it. Go to Program, go to the Frustum program, then do your radius 1 is 94.4 over 2. Your radius 2 is 0. Oh, okay, it doesn't like that. Fine. Over 2. Your radius is 0.000001, and your height is 123. And then you get your total surface area to be 2.65 times 10 power to 4. So you can actually use the Frustum program, which is probably way easier than doing this. And then the volume of a sphere. Well, the volume of a sphere is r cubed times 4 over 3 pi. So, and the radius is d over 2. Solve for d, and you get 5.29. Okay, Texas has a land area of that much. A map of the U.S. is scaled so that 1 inch is representing that many miles. What is the map area of Texas? So what you got to do, figure out is how many actual miles are in 1 square inch of the map. So that value is 112.5 squared. And once you have that, you do your land area, divide it by that, and you get the amount of inches on the map. And you use 4 SDs because you're multiplying everything, and your lowest number of SDs is 4, as you can see here. 37, pretty simple problem. Put both of these problems into Y1 and use EQ solver to find out when at what X value they're equal. Not too hard. Next, 38. Murray bikes 5 miles to school in 20 minutes and can walk in 1 hour and 20 minutes. The way to school, her bike broke down and she walked the rest of the way. It took her 47 total minutes. So we got to figure out her rate when she's riding the bike and when she's walking. So when she's riding the bike, she's able to complete 5 miles distance over in 20 minutes time. So 5 over 20 times time plus your walking speed, so 5 miles over 80 minutes spent on every minute you are not biking, so 47 minus x. And all that is equivalent to 5 miles. Now, once you have the time she spent biking, you can figure out how far from home she is by simply multiplying it by the speed to get distance. Okay, 39, very simple if you have a good program. SSF, or you go to triangle, pair circ, and you plug in every side. Ivan may be replacing this program in a bit, so you'd go to SSS instead, and then you'd continue, and it'd give you more info that you actually need. 40, pretty simple problem too if you have good programs. At SSA, or SAS, and then you get that side, and then you do SAS to figure out that side. 2 program uses in a row. Just make sure you record your numbers correctly, and you get 3.95. Okay, the Santa Maria weighs 50 pounds or tons and is 76 feet long. U.S. battleship is 860 feet long and weighs a bunch more tons. Battleship density is actually 2/3 of Santa Maria. What is the percent error in estimating the battleship using Santa Maria? Okay, so the weight of an object is based on the length of the side cubed. So in this case, it's 860 over 76 cubed. The original weight is 50. That would be the estimated weight if they were the same density, but since the battleship is 2/3, you have to multiply it by 2/3, and you'll get an estimate that is pretty darn close to 80 or 48,000. Then once you do that, you do your equation for percent error, 100 times estimate minus actual over actual. And if you do that correctly, you will get negative 0.620%. 47. Shirt size is measured by neck perimeter, and the amount of cloth is measured by the length of cloth in yards. So this is not actually quite a linear problem, as you can see here. What you need to understand is that the amount of cloth needed is based off of the surface area of the shirt. So you need to convert the neck perimeter into a surface area-like thing by squaring it. Surface area is length squared. You got to square each of the x values here. So you would do stat edit and plug in 12 squared, 15 squared, 16 squared, 17 squared, and then all the corresponding cloth lengths. And then you go to calculate, put it into Y1, or store reg as Y1, and Y1 of 18 squared. And then if you do that, you get 3.11 yards. 48, very simple. Put it right in EQ solver. Make sure your guess isn't negative so that it gets a number, so it doesn't give you an error. And if you do, you should get 29.3. Okay, 49. This is a pretty straightforward. Volume of the cube over pi. Okay, volume of the cube over pi. Each side's cubed over pi is equivalent to the pyramid, which is a square base times a height of x minus this x minus 0.956. That's the height, and then over 3. And if you do that, you get an x value of 1.87. Next one. This is a bit more complicated to explain, but I did do it on a 2019 test, and it could appear again. It's a pretty cool problem anyway, so I'd like to explain it. So what we're doing here is each of these sides is based on some Pythagorean theorem of two other sides. So what we can do is we can store this side as like y or x squared, and this side as, let's say this side is x squared, and this side as y squared, and this side as x squared. So you realize is that if you do, in this case, you get the 0.323. So this is your height squared plus your length squared is equivalent to your c value squared. And that idea repeats for each of the other ones. And if you do that, you plug that into a matrix. Then you go to matrix math, scroll up till you get to ref, put in the matrix you got there, and you look for the value that you assigned height squared to. In this case, it was the first one. So you take the square root of that value, and you get 0.144. You also ignore the fact that this rectangular prism is literally impossible because one of the x squared values is negative. I believe that's just an error on their part. I'm not going to complain though. Yeah, it's an invitational. Who cares? 56. Calculate the area on the curve. Just use f integral math. Scroll up fn int, and then do from 1 to 6 of this equation right here, and you'll get 117. 57. Bug population of 100 bugs doubles in 3 days. Birds eat the bugs, consuming 26 bugs per day. How many birds are needed to control them to just under 9,000? So this 100 is actually irrelevant because the maximum needed to control them to under 9,000, you have to have 9,000 to start with. So what you would do is you have your d over dx of 9,000. 9,000 bugs we're assumed starting with times 2 powered to x over 3. It doubles every 3 days, so if time is equal to 3, this value doubles. And then that value is subtracted by 26 times a number of days times some unknown amount of birds. And at x equals 0, the derivative of that will be equal to 0. And if you do that and solve for z, you'll get around 79.9, and you have to round up to 80. What is the determinant of this function? Pretty simple, or this matrix? Pretty simple. Go to matrix, plug it in, and go to matrix again, math, determinant, and put in the matrix, and you get negative 932. 59. This case, you plug these, we'll be using our OXOR program like normal on 59. You plug in the equations, x over 4x cubed and x over 3. And unfortunately, our OXOR no program doesn't work because this intersects again before 0, as you can kind of picture out in your head. So that means we do need to solve for the intersection. So just y1 is equal to y2 at some x value around 0.3. Or you could do like 1 or something as your guess. And then you'll get this value right here. Now you can use OXOR program. You do have inputs. Lower bound is x equals 0. Higher bound is x equals 0.2886. And your line of revolution is not relevant for this question. If you do that, you get a hatched area of 6.94 times 10 powered to negative 3. Okay, 60. For hatched area. So what you got to understand about this is you have to figure out this angle here. On these kinds of problems, it usually helps to draw lines like this that separate parts of the circle and triangles that can be formed from the circle. So in this case, this width here is r over 2, as you can see. They're equal length. And then the hypotenuse is r. So it is sine negative or cosine negative 1 of 1/2, which gets you 60 degrees. And once you have that, you got to figure out the length of this, which is equivalent to the area of the circle that would be like this, minus the area of the triangle that forms like that. So I'll show you. First off, it's done twice for both of these. Multiply by pi x squared times 60 over 360, because that's the amount of the triangle in it. Then you have to subtract that by x squared sine of 60. The area of a triangle is side squared, or area of a isosceles or equilateral triangle is side squared times your theta over 2. And once you have that, you have to also add this triangle inside here. So your bottom value is your base is your radius, and then your height is tangent of 60 times x over 2, and the area of the triangle requires you to divide by 2. If you do all that, assign it to equal to that value, and you will get an x value of 0.842. Next, okay, 61. How long do they align? We have a program for it. Program, clock, hours, minutes, done. 55.9 minutes. Probability of winning Powerball is that much. What's probability of winning 100 times? This is a very rare occurrence, so it is an underflow. Your value is 1 over 192 million, and that value is powered 100 times. And if you do that, it should give you this value right here. 63. This is going to be your kinematics program. Your question. Fortunately, our kinematics does have a way to solve this. You go to Kine 2D. The ball's maximum height is 15. It travels 78 feet, and it does not change vertically at the end. It is at the same height. That means you use x, y, z, plug in your change in x, your change in y, and your max y. And if you do that, you get a time of 1.93 seconds. Okay, now it's time for two of the hardest 6465 tests on any calculator test. Let's start with the harder one, 64. This entire problem revolves around finding this angle x right here. So the area of the two triangles are equal, this equilateral triangle and this isosceles triangle here. So the area of the equilateral triangle, pretty simple. Side squared over 4 times square root of 3. The area of the isosceles triangle, not so much. Okay, so we need to get it based off of this angle x. We'll find this value c, and we can use that to figure out the height and the width. So first off, we figure out our c. We use law of cosines, as you can see here. This gets you the value c right here. Now you square that. Now you do square that value because you're going to be multiplying it by sine and cosine. These are basically sine of this angle right here. And that angle is based off of the entirety of 180 minus the 60 degrees of an equilateral triangle minus this angle right here, which is equivalent to 180 minus this angle all over 2. And if you do sine of that and cosine of that, you'll get the height and half the width. So if you multiply those together, that is the height of a triangle. Or sorry, that is the area of a triangle, I believe. Yeah. And then if you do that, you finally get your angle x. Make sure you have a guess that's above 90 degrees. Otherwise, you'll just get 60 again. And then once you have that, you get your c. Then you have to do cosine of this angle right here we talked about, and then multiply it by 2. You get c with your SAS program. And yeah. So if you do all that, which you probably should spend your time on other problems on this test, but if you do it, you get 182. This is probably the longest, hopefully it's the longest EQ solver problem I'll have to write. And then there's even more you have to do after that. Next one. This one's also pretty difficult. So you're looking for the hatched area. The real problem is this stuff right here in the middle there, which means you have to use a bit of a unique approach to it. The best way I found is that you want to turn this into a kite, and then you subtract these two areas right here, and then add back on these two. So what you do is you have your 2x, or this angle theta right here, hypotenuse is 2r, and your vertical is r, so sine -1 of 1/2, and multiply it by 2 because it's dual-sided, and you get 60 degrees. So you do that, 2x squared times sine of 60, that's the area of a rhombus given a side length, s squared times your theta, sine of theta, and then you subtract it by 2 times your x squared times pi times 60 over 360, which are these things right here. Then you add back these two things right here, so 2 times x squared times pi times 240 degrees over 360 degrees, which is the amount this is. This angle right here is 180 minus theta, which is 120. So this entire thing is 240. You do all that, assign it to 3.53, you will get an R value or X value of 0.731. Thank you for listening. This was a bit of a pain to work through, but I did finish it.